2 plus 6i is a complex number. Remember, a complex number can be written in what form? A plus bi. Okay, so that's a complex number. Now, listen carefully, just in case they ask you this on my math lab. Okay, so there are two terms here. There's that 2 term, and then there's that 6i term. All right, so the 2 right here is called the real part. Now, I was using the word, I meant to use the word term last night, but I didn't. So I'm going to kind of go back to what I was saying. The imaginary part's not the 6i, that's the term. The imaginary part is the coefficient of the I. So what's the coefficient of the I? 6. So the imaginary part is 6. All right, so A is the real part, and the B is the imaginary part. So if I had, let's say, 8 minus 3i, 8 minus 3i, what is A here? 8. What is B? Negative 3, not 3, negative 3. So this is your real part, and this is your imaginary part. All right? So in my math lab, when they ask for the imaginary part, don't say, in this case, negative 3i, just say what? Negative 3. Okay? All right, now, if b does not equal 0, if b does not equal 0, then the complex number is called an imaginary number. Okay, so b does not equal 0. So if b is anything but 0, then that complex number is also called what kind of number? An imaginary number. Okay? So for example, 6 plus 5i. Is that a complex number? Yes, it's a complex number. Is this complex number an imaginary number? Yes. Because what is b here? 5. It's not 0. So b is 5. So this complex number is an imaginary number. Okay. The number 8. All the numbers that you've dealt with since you were born. You know, the first day you were born, you started counting. 1, 2, 3, 8. Is 8 a complex number? Can 8 be written in the form a plus bi? Some are saying no, some are saying yes. Who's saying yes? All right, Jordan, why?
Because if you put it in the spot for B.
You can put it what?
You can put it where B goes. So like A plus B, you can substitute it for B.
Okay, anyone else?
Is it an equal 0?
Say it again. All right. 8 is the same thing as saying 8 plus 0i. B is what here? 0. All right? So every number you've dealt with is a what kind of number? Complex number. 2.7 is a complex number. Pi is a complex number because I can write pi as pi plus what? 0i. So every number you dealt with can be written in the form a plus bi. In that case, b is what? 0. So 8 is a complex number. But here's the question. Is 8 an imaginary number? No. Because what is b? 0. In order for it to be an imaginary number, b cannot be what? 0. So 8 is a complex number, but it is not imaginary. Okay? All right, so they are going to ask you something like this in my math lab. Kind of that scenario. Okay? So 6 plus 5i is a so everything's a complex number, right? Okay, every number you dealt with is going to be a complex number. Some are going to be imaginary, some are not going to be imaginary. When will it be imaginary? When b is not equal to 0. When will it be when will it not be imaginary? When b is equal to 0. Okay. All right? Okay. Now, if a is equal to 0, if a is equal to 0, for example, 5i. If all I have is 5i, what is the 5 here? Is the 5 the a or the b? The b. So that means that 5i can be written as 0 plus 5i. Y'all agree? A plus bi? Okay, so what's a here? 0. So if a is equal to 0, then this, and by the way, is this a imaginary number or not an imaginary number? It's imaginary because what's b? 5. Okay, so this imaginary number is called a pure imaginary number. Okay, so this imaginary number is called a pure imaginary number. So in my math lab, they're going to ask you those words. They're going to talk about those words. So is the number 8 that we have here, is that a pure imaginary number? No, for one thing, it's not even a what? Imaginary number. So it can't be pure. Is 6 plus 5i, is that an imaginary number? Yes. Is it a pure imaginary number? No, because what is a here? 6. It must be what? 0. Okay. All right. Okay, now let's look at this. Do you remember and you did this in 99, not 98, but in Math 99 you did this. You talked about the word conjugate. Conjugate, C-O-N-J-U-G-A-T-E. Okay? And you use that idea when you rationalized a denominator. It was on your final last semester. When you rationalize a denominator. So for example, let's kind of review something from last semester. If I want to rationalize 1 divided by, let's say, 3 plus the square root of 5. 3 plus the square root of 5. Now this is last semester. The square root of 5 is what kind of number? Imaginary, rational or irrational? It's irrational. When it says rationalize the denominator, that means you want to make the denominator what kind of number? Rational. Okay. In order to do that, what did you have to multiply the numerator and the denominator by? The conjugate of the what? The denominator. And what's the conjugate of that denominator? Say it again? 3 minus the square root of 5. So what you did was you multiplied the numerator and the denominator by the conjugate. And the conjugate of the denominator is 3 minus the square root of 5. Okay? And so you just multiply this out, and notice what's going to happen. When I multiply this out, 1 times this numerator is just this numerator, right? Now, when I multiply the denominator, notice those are both what kind of numbers? Binomials, all right? And I'm multiplying 2 binomials, so what can I use? FOIL. What's 3 times 3? 9. What's the outer? Minus 3 square root of 5. What's the inner? Plus 3 square root of 5. And what's the last? What's the square root of 5 times the square root of, times a negative square root of 5? Negative square root of 25, which is just negative what? 5. What I want you to notice, though, is last semester when you multiplied these conjugates, what did you notice about the outer and the inner? They canceled out. And you're left with 9 minus 5, which is what? 4. And what kind of number is 4? Rational. So I rationalized the denominator, meaning I made the denominator what kind of number? Rational. So you had to like this in your final last semester. You may not remember that, but you did.
That one of them ones we got right at the end.
Yes, towards the end of the course. Yep. All right. Okay. We're going to use that same idea with complex numbers. Okay? All right, so listen carefully. The conjugate of A plus BI is what?
A minus BI.
A minus BI. Well, it's the same thing as the conjugate we just did, right? The conjugate of 3 plus square root of 5 is what? You'll see it. Who is it? 3 minus the square root of 5. You just changed the sign. That's all you did was change the sign. Okay, but this is a complex number, though, right? So your book's going to use the phrase, the complex conjugate. The complex conjugate of A plus BI is what? A minus BI. So, the complex conjugate of 6 minus 2i is what? 6 plus 2i. Okay? So the complex conjugate of 6 minus 2i, 6 plus 2i. Now that's going to be important in a little while, the idea of conjugate. We can use that same idea that we did last semester with these irrational numbers. So you understand now that to find the conjugate, you're just going to change the sign of that bi, right? That's all you do. So you put in standard form and then you change the middle sign. Basically, that's all you're doing. Now, when we did this one, when we multiplied these two binomials and there were conjugates, right? When I multiply these conjugates, always what's going to happen with the outer and the inner? They're going to cancel. So if I were to multiply these two complex numbers, and these two complex numbers are conjugates of each other, if I were to multiply them out, what can you tell me with the outer and inner? They're going to cancel out. All right, so let's see. So let's multiply these two. 6 minus 2i times 6 plus 2i. Now, doesn't it kind of look like the difference of two squares that you factored last semester? A minus B times A plus B? And when you did that, when you did the difference of two squares and you folded out, what happened to down the inner? They cancel. Same idea. Right? Same idea with the difference of two squares. What's the first? 36. What's the outer? Plus 12i. What's the inner? Minus 12i. Right away, you see they're going to add up to be 0, right? Now, what's a negative 2i times a positive 2i? Negative 4i squared. Okay, so I have 36 minus 4 times a what? Negative 1. So that's 36 what? Plus 4, which is 40. What's going to happen? What I want you to notice, and you're going to need to know this idea when we get through the rest of this section. When I multiplied these two irrational numbers right here, I ended up with what kind of number? Rational. When I multiplied these two imaginary numbers, these two complex numbers, these two imaginary numbers, I ended up with a real number. Did I end up with an imaginary number? No. You don't see an I, right? It's always going to be that way. So that idea is going to be important in a little while when we look at division. All right, so whenever you multiply two imaginary numbers that are conjugates of each other, you're going to end up with what kind of number? A real number. That's not going to be what? It's not going to be imaginary. Okay? All right. Now, we talked about adding complex numbers. We talked about subtracting. We talked about multiplication. Now we have to talk about what? Division. Division. And it's not going to be difficult. It's going to be easy. All right. So let's look at this one. So it's going to say divide, and then write in standard form. All right, so divide, and then write in standard form. Number 1, 4 divided by 5 minus I. 4 divided by 5 minus I. So this was, let's say, 4 divided by 5 minus the square root of 3. What will your next step? Multiply numerator denominator by the conjugate. Okay, same thing here. So the idea is when we rationalize this denominator, meaning we wanted to get rid of the irrational numbers. So what we want to do is get rid of this I. So get rid of this to make this imaginary number just a real number. We're going to multiply numerator and denominator by its what? Conjugate. You got to make the connection between this and this. Between Math 99 and college algebra. Okay? So what is the conjugate of 5 minus I? 5 plus I. So now, when you do your work, and I think the in-class worksheet is going to be one of these. When you do your work, I got to see this. So you can multiply numerator and denominator by the what? Conjugate. So you can say 5 what? Plus I, 5 plus I. So what I do to the numerator, I do to the denominator. Now you're going to multiply these two numerators. What idea are you going to use to multiply these two numerators? The distributive property. What idea are you going to use to multiply these two denominators? FOIL. Okay? So basically what's happening is this. You have 4 times what? 5 plus I, and the denominator is 5 minus I times what? 5 plus I. Okay? Now that was the hard part right there. The rest, you've had a couple of semesters of practice with what we're about to do, the distributive property and the fold method. So let's get rid of the parentheses in the numerator. How do we get rid of the parentheses in the numerator? Distribute. So what does that become?
20 plus 4.
Okay? All right, now let's use the FOIL method with the denominator. What's the first? 25. What's the outer? What's the inner? Minus 5i. And what's the last? Negative I squared. Okay? A negative times a positive is a negative. I times I is I squared. We talked about that yesterday. What happened to the out and the inner down here? You get 0. All right, now look carefully. See this denominator? See that denominator, right? In my denominator, I have this. I'm going to write it right here. I have 25 minus I squared. Y'all agree? Okay. What you may want to do is rewrite the way I'm doing this. You're going to say 25 minus, and then what is I squared? Negative 1. And then yesterday we talked about the fact that 25 subtracting negative 1 means the same thing as 25 plus its opposite. And what's the opposite of a negative 1? Positive 1. So that really becomes what? 26. So the numerator is 20 plus 4i. The denominator is what? 26. So that's where I'm at. So I multiplied numerator and denominator by the conjugate, and then I just used stuff I've learned from the last 2 semesters. Distribute and FOIL. Now the directions says write in standard form. So that means a plus what? The I. So you got to write this as 2 separate fractions. So you're going to say 20 divided by what? 26 plus 4i divided by what? 26, and then reduce. So what's going to be the answer? What's 20 over 26 reduced? They're both divisible by 2, right? So that's 10 over 13. And then 4 over 26 are both divisible by 2, so that's 2i divided by what? 13. So there's your answer. So standard form, a plus bi. What's a for your answer? What's the real part? What's the real part? 10 13. What's the imaginary part?
2 over 13.
No I is just what?
2 over 13.
2 over 13. 2 over 13. Okay, all right, let's do another one. Okay, so look at number 2. So it's not that difficult. It's very easy. You can... No, can I have $1 every time I say that?
Use it to pay for this class.
Okay, quick question.
Well, let's hope you don't do that.
I have a question.
Yes.
On the, second part, the 2i over 13, is it 2 over 13 and then I?
Yeah.
That's
So,
the I
well,
and
it
the I
depends.
and the fraction.
Okay. So there are a couple ways you can write this one. Her question is this: how do I write the imaginary part? So you can say 10 over 13 plus 2/13 I. That's an I. Okay. It is okay. Now in Math Lab, they're going to want the coefficient of I being 2/13. Okay. Or if you want to, you can write it as 10/13 plus 2i divided by 13, just like that.
You're saying I'm mathematically going to want it the first way that you wrote it?
Yes, like this. All right. Now, you can attempt, remember you get multiple attempts, so you can attempt to write it like this and see if it passes, see if they give it to you. They probably will, but this is what they would probably want. But either one's fine. Okay, number 2, you want to divide these 2 complex numbers. They're complex numbers, right? Is -2 a complex number? Yes, every number you dealt with since you were born has been what kind of number? A complex number. It can be written in what form? A plus bi. Negative 6 is the same thing as saying negative 6 plus what? 0i. But I'm dividing these two complex numbers, meaning that you don't want the denominator to be what kind of number? Imaginary. I'm glad you used that word, imaginary. You want it to be just a real number. So I need to get rid of that I somehow. You multiply numerator denominator by the what? Conjugate. What's the conjugate of 3 plus 5i? 3 minus 5i. So what you can do now is this. You're going to say, all right, I'm going to multiply numerator. Let me kind of rewrite this. So negative 6 over 3 plus 5i. So you're going to say times. When you do your worksheet and we do your test, you're going to say times. What will I put in the numerator?
3 minus 5i.
What will I put in the denominator?
3 minus 5i.
Okay. Then the next thing you're going to write, you're going to see how I have these two fractions being multiplied together? You're going to write this as one fraction now. So in the numerator, you're going to say negative 6 times what in parentheses? 3 minus 5i. In the denominator, you're going to say what? Tell me what to write. In parentheses, though, right? Okay, so 3 plus 5i times 3 minus 5i. So that's the procedure. It is, you got to make a connection between that and what you did with rationalizing a denominator in Math 99. Now, let's get rid of the parentheses. How do I get rid of the parentheses that's in the numerator? Distribute. So what's negative 6 times 3?
Negative 18.
What's a negative 6 times a negative 5i?
Positive 30i.
Okay. All right, now let's do the denominator. How do I get rid of the parentheses in the denominator?
Foil.
Foil. What's the first? 9. What's the outer?
Negative 15i.
What is the inner? Better be positive 15i, right? Because remember the difference of two squares that I did last semester when you factored? The outer and the inner were opposites. Now the last. Now I want you to notice something. These are conjugates, right? So the one will be positive, the other one will be what? Negative. So a positive times a negative is a negative.
Negative 25i.
I squared, yes. All right, now the out and the inner cancel out, right? Okay, so I'm left with negative 18 plus 30i divided by, now let's go off to the side and figure out what that denominator is. So my denominator is 9 minus 25i squared. But what is I squared? So that's 9 minus 25 times negative 1. A negative times a negative is a positive. So that's 9 plus 25, which is 34. So that's your denominator. But it's going to ask you to write this in standard form. So just rewrite in two separate fractions. So you're going to say negative 18 divided by 34 plus 30 divided by 34i. And then just reduce. Negative 9 over 17. And then 15 over 17. Is that correct? I. So there's your answer. It is not difficult. Yes? It says write in the form, write in standard form. Standard form means A plus BI. Okay? So always follow the direction. If the direction didn't say anything about writing standard form, then you could have said negative 9 plus 15i divided by 17. But if it says write in standard form, you got to write it as A plus BI.
And we have to add that I to leave it off to
Okay, say it again.
the I. We have to add it and just leave it off from the front.
Yeah, you got to have it because that's part of your answer, BI, right? see you have it by there. Okay. All right. Number 3. 6i divided by 3 plus 2i. 6i divided by 3 plus 2i. I'm dividing complex numbers. The denominator is an imaginary number. I don't want it to be an imaginary number. I want it to be what kind of number? A real number. Okay? So notice that when we did number 2, I went from an imaginary number. I went from an imaginary number to what kind of number? A real number. 34 is not an imaginary number. I want to do the same thing here. So how do I get rid of this I that's in the denominator? Multiply numerator and denominator by its conjugate. And what's the conjugate of 3 plus 2i? 3 minus 2i. All right, so you're going to say times 3 minus 2i in the numerator, and then 3 minus 2i in the denominator. So what you do to the numerator, you have to do the denominator. Those are still equal to each other. See those two expressions here? They're equal to each other because anything divided by itself is what? Anything divided by itself is what number? 1. See, that's 2. That's a 1 right here. 1 times this is still this. Okay, now I'm going to write this as one fraction instead of 2 fractions multiplied together. I'm going to write this as one fraction. So you're going to say 6i times 3 minus 2i divided by, and then 3 plus 2i times 3 minus 2i. All right. So some of you, and I asked you to do this yesterday when you got that worksheet, I said for you to go ahead and start working on that worksheet that I gave out yesterday on 1.4 part 2, and some of you did. So you did something like the numerator when you did that. So what procedure do you use to get rid of the parentheses that's in the numerator? Distributive property. So you're distributing 6i this time, right? Before you were distributing a real number. Now you're distributing 6i, which is an imaginary number. When I distribute, though, I get 6i times 3 is? 18i. 6i times a negative 2i?
Negative 12i squared.
Okay, good. So I get a negative 12i squared. Now let's talk about the denominator. How do you get rid of the parentheses here? Foil. 3 times 3? 9. What's the outer?
Negative 6i.
What's the inner? Okay. Now the last. What's a positive 2i times a negative 2i? Negative 4i squared. All right, so that's where I'm at. Now let's talk about the numerator. Remember, I squared, you're going to rewrite it as what number? Negative 1. So the numerator is really this. 18i minus 12 times what? Negative 1. Okay? That's the numerator. The denominator, the out and the inner cancel out. That's 0. You're left with 9 minus 4 times what?
Negative 1.
Negative 1. So that's my denominator. Negative 12 times a negative 1 is what number? Positive 12. So do y'all agree that in my numerator, I can write this as 18i plus what? 12. The denominator is 9 what? Plus 4. I can go further with this. Now, before I go any further, remember the directions will say write in the form, write in standard form, right? So it will be a good idea at this point to rewrite 18i plus 12 as what? 12 plus 18i divided by, and what's 9 plus 4? 13. And so what's the answer? 12 over 13 plus what? 18 over 13i. That's your answer. Okay? All right, number 4. All right, number 4, you have 4 plus I. So notice the difference between the numerator of number 4 and the numerator of the previous 3 problems. The numerator of the previous 3 problems, you had a monomial, just one term, right? Here you have a what? A binomial. So it's going to be a little bit more work for this one. All right, so 4 plus I divided by 2 minus I. All right, so I'm dividing these two complex numbers. I don't want an I in the denominator. I don't want an imaginary number in the denominator. I want this to be just a real number. So what will I multiply numerator and denominator by? The conjugate of the denominator.
Denominator, so 2
What's
plus I.
2 plus I. So you're going to say times 2 plus I divided by 2 plus I. So what I do to the numerator, I do to the denominator. Now I'm going to write this now as one fraction. So the way you're going to write this, you're going to say in parentheses 4 plus I times what? 2 plus I. The denominator, you're going to say 2 minus I times what? 2 plus I. In the previous 3 problems, when we got rid of the parentheses in the numerator, we used the distributive property. This time we're going to use what? FOIL in both cases. All right, so let's do the FOIL for the numerator and the denominator. What's the first numerator? 8. What's the outer? 4I. What's the inner? 2I. What is the last? Plus I squared. So that's my numerator. So 8 plus 4I plus 2I plus I squared. The denominator are conjugates. So when I add the I and the inner, I'm going to end up with those two adding to 0, right? All right. So let's talk about the denominator. What's the first? 4. What's the outer? 2I. What's the inner? Negative 2I. And what's the last? Minus I squared. All right, so that's where I'm at.
Is there any way that thing would zoom in?
Say again?
Is there any way that thing will zoom?
Zoom in.
No, to make everything bigger.
I mean, this.
That is so much better.
Okay, so let's talk about the numerator. What are you going to do to the numerator? Combine like terms and also rewrite I squared as what? Negative 1. So I get 8. What's 4I and 2I? Plus a what? Negative 1, because I squared is equal to what? Negative 1. All right, let's talk about the denominator. I have 4. These cancel out, right? So I'm going to say 4 minus and then what? Negative 1. So that's where I'm at. Let's go back to the numerator and combine like terms. What can I combine in the numerator? Which gives me 7. So that's 7 plus 6I divided by, now what's the denominator? 4 plus 1, which is 5. And so what's the answer? Yep, that's the answer. So they ask you to write it in the standard form. That's what you're going to write. Okay? Now let's do one more with this. Number 5. Number 5. You have 7 minus 2I divided by 5 minus 3I. So 7 minus 2I divided by 5 minus 3I. Okay, so the direction is going to say divide. That's all it's going to say. is it's going to say divide. You have to know that to divide this means you got to do what?
Conjugate.
Multiply numerator, denominator, conjugate, because you want the denominator to be what kind of number? A real number. Right now, it's what kind of number? Imaginary. You have that I there. All right, so all it's going to say divide. You have to know what that means. So you're going to say 7 minus 2i divided by 5 minus 3i, and then we'll multiply numerator and denominator by the conjugate of the denominator. So it'll be 5 what?
5 plus 3i.
5 plus 3i. 5 plus 3i. And now I'm going to see how I'm multiplying these two fractions. I'm going to put it as one fraction. So you're going to say 7 minus 2i in parentheses times what?
5 plus 3i.
5 plus 3i in parentheses divided by, and then what?
5 minus 3i in parentheses. Plus 3i.
5 plus 3i. Okay. Now what's the next step? You're going to FOIL. So what's the first? 35. What's the outer? 21i. What's the inner? Negative 10i, right? All right, now what's the last? What's the negative 2i times a positive 3i?
Negative 6i squared.
Negative 6i squared. Divided by? All right, let's talk about the denominator now. What's the first? 25. What's the outer? Okay. What's the inner?
Negative 15.
Now, what's the last? What's the negative 3i times a positive 3i?
Negative 9i squared.
9i squared. So that's where I'm at. So all I did was FOIL in each one. Now I'm going to go back to the numerator and kind of combine some like terms and also rewrite I squared as negative 1. All right, so in my numerator, I have 35. What is 21i and a negative 10i? Positive 11i. And that's, I'm going to say minus 6 times a what? Negative 1. Now let's go to the denominator. 25. These cancel out because a positive 15i and a negative 15i is 0. Minus 9 times what? Negative 1. Okay. Now, this negative 6 times a negative 1, that's really a what? Positive 6. So tell me, what is 35 plus 6?
41.
So 41 plus 11i. And this is 25 what? Plus 9, which is 34. So what's the answer? If it doesn't say anything about putting in standard form, then you can leave it like this.
So 41 over 34.
If it says write it in standard form, then you're going to say what?
41 over 34 plus 11i over 34.
All right. And that's it. Okay? All right. Now, it's very simple.